Good day, my name is Richard and a warm welcome to Tutoring with Richard, where we cover the South African school syllabus and netted topics. Today we're going to cover strength of materials in 6. The topic of this tutorial is thick cylinders, example 2.2. Let's get straight into it. First thing we've got to realize is to ask, now we've first got to read the question. A hydraulic press with a ram diameter of 80 millimeters is used to lift a load of 10 tons. Assume the inside diameter of the cylinder is the same as the ram diameter. The tensile stress on the cylinder wall is 54 megapascals under the load of 10 tons. Now, calculate the minimum cylinder wall thickness needed for this load and 2, the longitudinal stress in the cylinder wall. Okay, so first what we need to do is to draw our we need to draw our graph. Now this is positive and that's negative, 0 and 0. Now, we don't know what our radial stress is, but we do know what our hoop stress is. Hoop stress, our maximum hoop stress, is the tensile stress. So hoop stress is tensile. So what I'm saying is that your positive is your compressive stress, and your negative is your tensile stress. Tensile is a pulling force. Compressive is a pushing force. Okay. So now we know our tensile force, which is a negative force. That's why it's down here. So it is minus 54 megapascals. Now, how are we going to calculate? We need to calculate our load. Well, we first need our internal pressure, which is a compressive force, because it's acting on the inside, so it's compressive. So what we need to do is state, first of all, is our values. So small d equals 80 millimeters, and we don't know big D. We don't know that. So what they want basically is a wall thickness for the first sum. They want a wall thickness. So how we're going to do that is we're going to calculate D and then minus 1 from the other. So small d is 80 millimeters. Our hoop stress at 80 is minus 54 megapascals. Our R, our radial force, we don't know just yet, but we will work that out now. Because we will need it. We will need it because we are going to combine. We're going to combine our two formulas. So, RH at 80 equals minus 54 times 10 to the 6 equals A minus B over 0, 0.08 squared. Okay. So we're going to get those now. Now what we're going to do is work out our radial. radial load. So now our load, our internal pressure is equal to load over area. That's what it is. So, what is our load? 10 tons. So 10 times 10 to the 3 multiplied by 9,81. You got a sneeze, you got a cough. And what was that? Times, so your force times your gravity gives you your weight. Now, pi over 4 is our area times 0,08 squared. Right. And our internal pressure is 19,52 megapascals. Right, so that is 19,52 megapascals. Alright, so now what we have is R at 80 is 19,52 times 10 to the 6 equals A plus B over 0,08. 0,08. Squared. Okay. Now, what we're going to do is, since we've worked that out, we're going to put these two sums together. Now, if you will remember how to do simultaneous equations. Let's see if we remember how to do simultaneous equations. So, minus 54 times 10 to the 6 equals A minus B over 0,08 squared. Now this is 19,52 times 10 to the 6 equals A plus B over 0,08 squared. Okay. Now what this is saying, now we've got two equations that are very similar, but there's a slight difference between the two. Let's add them together. 54 minus 54 plus 19. That will give us minus 34,48 times 10 to the 6 equals. Now we've dealt with that side. Minus b over 0,08 squared plus b over 0,08 squared. Those two cancel each other out. A plus A is 2A. Very simple math. Now all we have to do is divide that by 2. Divide that by 2. 2 and 2 cancel. And this becomes minus A is equal to minus 17,24 megapascals. So A equals minus 17,24 megapascals. Now all we have to do is work out B. So how we work out B substitute into equation 1, which is this one here, the 19. So, because it's a positive number. So, equation 2, sorry. So, 552 times 10 to the 6 equals A, which is minus 17,24 times 10 to the 6. Now, this is plus B over 0,08 squared. Now what we're going to do is bring this over to this side. So it becomes 34,48. Actually it's not. It's 36. 19,52 plus 17,24 equals 36,76 times 10 to the 6 equals B over 0,08 squared. Alright. So this will multiply with this. So multiply 0,08 squared. So multiply 0,08 squared. So then we will get B. 0,08 squared multiplied by 36,76 times 10 to the 6 equals 0,235. B is equal to 0,235 times 10 to the 6. Okay. Now what we can do, with that is now that we have A and B, we can work out our wall thickness. So, when R is at 0, we know that number. So, this will be 0 equals A plus B over D squared. Right, so we have minus 17,24 times 10 to the 6 plus 0,235 times 10 to the 6 all over D squared. Right, so what we do is bring this over here. We bring that over. Now we bring this over, so it's 17,24 times 10 to the 6. Okay. Now equals 0,235 times 10 to the 6 over D squared. Right. So this comes down here now. So it's divided by 0,235. And then this is 1 over D. So because it's 1 over D, we actually invert that. We invert both. So this will become 0,235 divided by 17,24, both times 10 to the 6, times 10 to the 6, equals D squared. Now we square root that and square root that, and that cancels with that, and we're left with D. So all this will calculate down. All this will calculate down to equals, so D, let's get D. D equals 116, comma 75 millimeters. That is what it ends up as. Because that and that cancel, because they're both divisions. 0,25235 divided by 17, comma, that'll give you a number. So let's put in our calculators quickly and make sure our math is correct. 0,235 divided by 17,25, all rooted. And we have, 24, 17,24. Yes, and we have it, it comes out as D equals 0,11675 meters. But we want it in millimeters. So, what we do next is we take them and we minus one from the other to get a wall thickness and divide by 2. Because a diameter minus a diameter gives you another diameter. So, we need to divide that by 2 to give us a wall thickness. So, it is D minus D over 2. This is our wall thickness. Our wall thickness is 116,75 minus 80 divided by 2. Put that in your calculator and you get 18,38 millimeters. And that is our wall thickness for all intents and purposes. Next sum. We're going to calculate the longitudinal stress now. How we do that is by this formula, or by these formulas. Right. Pressure internal, pi over 4d squared is equal to, now this is stress longitudinal times pi over 4 d squared minus d squared. Okay, so let's make this as simple as we possibly can. Right, so now we want our longitudinal stress by itself. So what can we do? That can cancel with that. So we're left with pi d over 2. So then what we do is we take this d squared minus d squared and we put it underneath here. So d squared minus d squared. Alright. And that is our sum. That is all we have to do. That cancels, and we got that. And this cancels, and we have that. So we have our internal pressure, we have our small diameter, and we have our large diameter. That is all we need to calculate our longitudinal stress. So, what we're going to do now is our internal pressure is 19,52 times 10 to the 6 multiplied by 0,08 all over 0,116775 squared minus 0,08 squared. Okay, all we need to do now is to calculate. Put that in your calculator, and you'll get 17,278 megapascals. That is our final answer. You just have to know your formulas. So, longitudinal, 17,278 megapascals. If you found this tutorial helpful, please give it a like and subscribe. It costs you nothing, and it really helps with the algorithm and to grow the channel. Positive feedback is most welcome. I enjoy reading your comments. Please use the comments section to let me know what topics you'd like me to cover in upcoming videos. Be at peace, be kind to each other, and remember, passing well is achievable. Have a great day. Looking forward to seeing you in the next video.